Hi, YouTubers. Dave out in Western Pennsylvania, USA. I'm continuing along with my study of graphite components in a series circuit with two commercial supercaps. I'm using alligator clips because I'm not moving anything around doing preliminary studies. Here's the electronic load device, ZKE Tech, model A10H. If you want to do cycles of charge discharge, A10H, not A20H. However, this is a step analysis power output study that I'm doing here. So I have them in series, and that means each one rated at 2.8 volts, capacitance 100 farads each. By putting them in series, of course, the capacitance would be cut to 50 farads, and the potential for the system would then be 1.8 times 2, 3.6. 2.8 volts times 2, 5.6 volts. I don't go up that high a potential because I'm working with graphite felt. Here's a typical sample. And coated with deep eutectic solvent electrolytic solution. This one is anhydrous zinc chloride, 1-to-4 mole ratio with acetamide, easily prepared and reported to be, and we see it as a liquid at 20 degrees Celsius. A couple of stainless steel clips for leads, current collectors. The dimensions of the graphite, this is very important, of course. 48.6 millimeter length, this sample, 17.6 millimeter width, and the thickness, 2.8 millimeters. That should always be recorded, of course, when you're studying a sample. So we put that right in series, and we connect the graphite. In this particular study, no packaging to seal it, just preliminary runs, and we insert the graphite sample directly to the black or negative lead, one end. The other end hooks up to this capacitor I'm showing you right here. And then you have your series. That way, I could do charge-discharge studies with a graphite sample without having to build a supercap with two graphite electrodes, of course. Preliminary data before building a supercap. We study graphite components, oxidized materials, electroplating with nickel or nickel cobalt alloys. We're going to deposit organic semiconductor polypyrrole down the road. And this is commercially available, this felt. Now, what you see up here, and I'll be putting this data and graphs at my website. I'll put the link down. You can see that this would be a typical run, and this would be the series caps only, as shown. The graphite is not in the circuit. And this will give you an idea of the power output if you, for each step, multiply the current in amps times the volts. Here's the data. Let me call that up. And here, with Excel, you'll be able to see the 10-second intervals and the current and voltage for every 10 seconds. That's what we study. And if you multiply for any given point the voltage times the current, you'll get the power output in watts. We want to see how the graphite performs in this series circuit, of course. So I'll upload this if you want to inspect this data and attempt to reproduce it. Now here is the graph with the graphite sample in the circuit, series hookup. And here is the data. So you'll be able to inspect the data collected. Now, I should make this clear. Let me open up the EB tester. I don't have it connected. Maybe I should, for argument's sake. Okay. And when we do an auto test, for those of you wanting to get involved in this type of research, you then set your parameters. Now, I use a starting current here of 0.1 amp. I stop at 1.0 amp. The cutoff voltage I use is 0.30 volts, not 0.8. And each step is 1/10 of an amp. So that will proceed over 10 steps. We go from 0.1 amp to 1.0 amp. And then we do the change every 10 seconds. So here are the numbers I actually use. We stop at 1.0 and 0.3. This is for the benefit of those wanting to get involved, undergrads or home researchers. Okay, so that's what we use to generate the data. It's a good range of variables. Now, what do we see? Anything of interest? Okay, here's some numbers. I happen to write them down for the video. With the 2 supercaps only, here are the first 8 data points. On the left, current. The first one there at the top column, 0.1 amp. And then I have written down the wattage, 0.4 watts. Second step, 0.8. 1.2, 1.5. Notice I put a line there because that's where we're going to see a difference with the graphite in the series. Half an amp, 1.8 watts output. 6-step, 600 milliamps, 2.0 output. See the wattage going up as the current's going up. 0.7, 700 milliamps, 2.2, 2.3. Now pay attention to 4 and 5, if you will, where it goes from 1.5 watts at step 4 to 1.8 watts at step 5. Now here is with the graphite sample in there. Incidentally, the run after charging up at potentiostatic, constant voltage, we bring up the supercaps to 4.6 volts, and then we start the run. Now, with only the 2 supercaps, after we trickle charge to 0.15 amp cutoff, the potential then dropped from 4.6 to 4.455 at the start of the study. There are those numbers. That's only the 2 with the 2 supercaps. Now, once again, with the graphite felt, if you look at these numbers, after step 4 and step 5, you can see 1.2 watts and 5 is 1.3 watts. But if you don't have the graphite component, 4, 1.5 watts, 5, 1.8 watts. And then it's going up to 2.0, 2.2, 2.3. Now that's with only the 2 supercaps. Now with the graphite there, it seems to be doing okay until just about step 4. And that would be at 400 milliamps. 5 would be 500 milliamps. So we're at 1.2, 1.3. With the supercaps alone, step 4, 1.5, 1.8, but then going up, see? Whereas with the graphite there, after 4 and 5, Power is dropping. So right now, that means you could probably use this graphite to hold its own, not building up resistance, at about 400 or 500 milliamps. If you stay at a lower current, then it'll be almost on a par with the supercaps by themselves. Now, please keep in mind the dimensions of the felt and the particular deep eutectic solvent and electrolyte. We're using here, once again, anhydrous zinc chloride, acetamide, organic material, 1 to 4 mole ratio, and about 18% mass of anhydrous lithium bromide electrolyte, which dissolves. You might have to gently warm it and stir it, not too much, bring it up to body temperature or so, and stir until it dissolves. And even after a week at 20 degrees Celsius, the lithium bromide does not come out. Now, I don't use lithium iodide, but that's another story. I'm worried about oxidation of the bromine. But record the dimensions of the graphite, whether you cleaned it or not. We usually clean them with 95% ethanol and dry to constant mass. Measure the dimensions. Make sure your hookups don't have loose wires. And of course, the circuit I'm using here, the wire, the copper 18 gauge or so is a conductor, of course. It's not a superconductor. There's going to be a little bit of resistance. But it enables you to compare a sample of graphite dry or wet with DES electrolyte and be able to get some data compared to the supercaps alone. It's an excellent introduction, and it doesn't cost a lot of time or money, particularly for undergrads or home researchers, to experiment with different graphite samples. Now, I have graphite yarn. This is graphite felt. And we do nickel plating. We do oxidation of graphite and sonication of graphite. And then we'll continue to get scanning electron microscopic images before and after these power output studies. And then we do cycles of charge-discharge. We've been up to 300 cycles with graphite samples. I want to see if the DES electrolyte can hold up at 3.7 to 4.2 volts. And of course, we'll go up to about 500 cycles. In industry, they'll go up to 500,000 cycles. But if there's going to be a problem, we should be able to see it early on. And that's the value of this very simple first approximation before going on to using potentiostat, EIS studies. Actually, you're doing resistant measurements here due to the graphite component. And by looking at the changes in power. We'll keep you posted on what we're doing, but this is to get my undergrads up and running. And then from here, you begin to study impedance, cyclic voltammetry. We'll even get to the point that we squeeze the DES out of the felt after a number of studies and run the Fourier transform infrared before and after to look for any changes with FTIR. But this is an excellent way, in my opinion, for undergrads all over the globe to get up and running with Supercap research. And some interesting data can be generated. So anyway, thank you so much for watching. I'm going to put this data at my website. I'll list the link. Thank you for watching. Bye for now.